It's a pleasure to see you, all of you here on this session on Saturday evening to spend some time to know more about electric vehicle and possibly more of the technologies involved in electric vehicles. So I welcome all of you on behalf of Competences Factories and Anand Lal Electric to this webinar on electric vehicle technology. Maybe it's always good to give some a brief idea on what we do. So before jumping into the topics, I'll just run you through a little bit about what is Competence Factory is, and the key speaker introduction to a key speaker and the company. As a Competence Factory, we started in 2017 May. It's been close to an year by now. So we have been involved in organizing a lot of training programs in many different areas of automotive. Nothing in specific, but we like automotive as much as possible. So we majorly is into automotive. So yeah, the screen full of programs laid over here has been a part of our modules for the training and delivery. Maybe it could be an engine management system or powertrain such as an ICs or motorsports ECU building. A lot of these programs which I have been organizing. So the sole place possibly for anyone who is interested in automotive is a place where you can come to us and learn more about technologies in automotive and even to a certain extent of R&D. That's what we do in overall as a Competences Factory. We conduct training programs, we organize skill development activities across the country. As a part of all of it, so we see an EV revolution, electric vehicle technology revolution going on in the whole world. Yeah, we are also in the pace with it, maybe mandatory or not mandatory, it's a government or not a government. We have so many of these reasons, but there's still good amount of push from government to make electrics certainly a part of mandatory thing. Keeping in that all the same lane, we could sense that there are a lot of opportunities for young engineers or experienced engineer, or I would say domain-specific engineers to work in electric vehicle technologies. So, I mean, the whole idea of the workshop is to kind of get a head around with electric vehicle and technologies that are involved in it, to understand more about what exactly the systems are in place. So that's, in a nutshell, what is going to be covered as a part of this webinar. Anything more than that, we can definitely have an offline chat, or maybe we can have one more webinar coming up if you can post us in specific requirements. So the session is delivered by one of our partner, that's Anand Lal Electric. It's a company based out of Bangalore. Majorly work on retrofitment of electric powertrains into maybe two-wheelers or even into a bigger vehicle segments. The founder of Anand Lal Electric is Mr. Setharaj. So he has a vast experience in the area of electric vehicles. He himself has worked with a lot of projects in electric vehicles till date. His core area of expertise into system integration and major domain comes in the area of motor and motor controllers. So it's an amazing startup based out of Bangalore. So they have been working wonderfully in the area of electric vehicles. It was a great pleasure for us to partner with Anand Lal Electric to host this program on this day. Nothing would have been possible without them to host this program. So that's in a brief introduction. So I definitely hand over the session to Mr. Setharaj to take care the further delivery. I request you to also introduce a bit more about Anand Lal Electric, and from there on, the whole session can be taken care. So yeah, here we go. Yes, Mr. Setharaj, this is I handed over the session to you. So from here on, you can take up the whole session ahead.
Thank you,
and pleasure. Thank you very much. It's all over, and hand over to you. Thank you.
Thank you. Good evening. Is the screen visible to everyone? And am I audible? Hello.
Sir, audible.
Hello? Sir, audible. Yeah, you're audible. We can see your screen.
Okay. Good.
Yeah.
So here, I would like to thank Competences Factory for giving us the opportunity for this webinar. Here, before getting into electric mobility systems, and how, what is the future, and what was the history, and what is the current state of the art. We'll first go into what is our company and then what we do. We have been incorporated as a private limited company since 2015 March, and basically we are into R&D, manufacturing, and marketing and sales of specialized electric mobility systems. Basically, integration of electric drivetrains for commercial vehicles. Mostly, our customers are B2B customers on the logistics side, and our mission is to develop reliable as well as economic electric transportation for both public and personal use. And we also provide all help and training to those people who are interested in getting into this business, as well as to build their own sustainable transport systems, because we believe that uh, by collaborating with each other, we will be able to build a better future. So the company is, I myself, Seturaj, handle the technology and development part, and I have about 15 years plus work experience in different areas of engineering. And the sales and marketing is handled by Mr. Swatiraj, and Ms. Rishmi, she handles the software systems. We have contract employees who do the integration work based on project basis. Now, before we start about what is the state of the art, it would be much better if I would tell you something about how the electric vehicles have evolved. And many of you would be surprised to know that there, at one point in time, electric vehicles used to be about 30 to 40% of the total vehicles sold in the world. So around the mid 19th century, the electric vehicles were used in a very commercial way. What you're seeing in this picture is a Detroit Electric Model 47. It is used as a taxi vehicle, and this was very popular during the 1900s. So if you see, from the time from 1827 to 1839, very lot of pioneering effort has been done in this field. From Hungary, some scientists from Netherlands, some people from US, and some people from UK. All these people, they were working on different electric models, and very viable electric motors as well as electric locomotives, all based on both rechargeable as well as chargeable, non-rechargeable or primary cells. These were being done in this time. So now those of you in Bangalore, you would have seen taxis, electric taxis, specifically run by lithium technologies. Now we would be seeing this as kind of a novelty, but it would surprise you that in 1884 itself, there were electric taxis, and there was a company called Electric Construction Corporation, which was promoted by an English inventor called Thomas Parker. So this idea of electric transportation was nothing new, because inherently, even though we talk a lot about the carbon footprint as well as pollution part of IC engines, electric vehicles score on one part. They are, even if you don't consider the carbon footprint, inherently they are more efficient. They are more silent, and there are no tailpipe emissions and noxious gases. So this was of much importance in a time when coal was a primary source of transportation. So you can see 1897 to 1900s, that could be called as the golden age of electric vehicles. At this point, in around you could see 22% of the vehicles sold in the US. USA is the largest market of automobiles, and only 22% was powered by the IC engines, whereas 40% of it was powered by steam, and 38% by electricity. But how did what caused this decline in electric vehicle propulsion was, at one point of time, the road infrastructure, it went up in a very big manner, and the electric range as well as the speed of those vehicles could not catch up. because transistor was not so popular in that time. It was only very much stabilized during the 1950s. So the speed control of electric motors, it was not so much possible during that time. That was one reason. Second reason was there was the large deposits of petroleum could be found, and mass manufacturing of IC engines by Thomas by Henry Ford, that also brought down the price of gasoline powered vehicles. So the decline started from 1900s, or rather from 1920s. So the car which you are seeing in this picture, it is called as a Henry kilowatt. It would surprise you to know that the battery company called Excite, they were the promoters of the company that built this vehicle. This vehicle could achieve a speed of 90 kilometers per hour with a 72-volt system. So we could see that from early 1800s to 1920s, we saw a rise as well as a golden age as well as a decline of electric vehicles. But then afterwards, in the 1990s, there is a revival of interest in electric vehicles. This came about because of tighter emission norms. Then a lot of hybrids and plug-in electric vehicles that used to be made. Some of these vehicles were like the Honda EV, Toyota RAV, GM. General Motors had a model called the EV1 as well as an S10 EV pickup. There's the Toyota Prius, which was a hybrid. Reva I, or the Reva, which is our own Bangalore-based company. They had sold about 4,000 plus vehicles till 2011 worldwide. And the largest vehicle in terms of sales was a GEM NEV. NEV is what we call as a neighborhood electric vehicle, which is used for a shorter duration. About 45,000 units were sold in 2010. Now, if you see the present state, we could see that the earlier vehicles, what we were seeing, these were not highway capable vehicles. Most of these were used for they were they could be used only for a shorter duration, maybe less than 100-kilometer range in that category. So here we see that since 2009 till 2000 till date, we could see Mitsubishi, Chevrolet, Nissan, Renault, and many different players. They have got so much vehicles on the road. If you see this swappable battery technology that you're seeing, which is also currently being floated very much, this was successfully done by the Better Place network in Israel and Denmark. However, it could not sustain for a long time, and the company wound up. Now, another point that we need to consider when we speak about electric vehicles is electric vehicles, even though they are driven by electricity, some proponents say that anyway you are using the what is called as typically called as a dirty electricity, or electricity that is generated with coal, that is driving your EV. Analysis. The effort that is taken to drill the petroleum, transfer to your car, and adding up to the efficiencies of the car, comparing that to generating electricity through natural gas or coal, and then using it in the car, and then comparing which would be better. If we see, we have, if for that, for understanding that, first of all, we need to see what are the different vehicle technologies and what are the fuels and how do we get these fuels. So we can have the vehicle technologies classified as nearly 4 different categories, which is a spark ignition vehicles, which is your run by petrol or ethanol. Then there are the compression ignition vehicles, which is done by the low sulfur diesel or HSD, and battery electric vehicles, which are purely driven by electricity, as well as fuel cell vehicles, which is driven by hydrogen. The hydrogen gas is used in a fuel cell, which then again drives the fuel cell produces electricity, and byproduct is just water. So if you see the gasoline, and gasoline is the feedstock is 82% Means what this means is 82% of the petrol it is got usually from the crude oil, and about 18% from oil sands. Ethanol is a much better source because it is from a renewable source such as farm output like corn or herbaceous biomass. Whereas diesel again same as petrol, which is from 82% of conventional crude as well as 18% from the oil sands. Now, if we come to the battery electric vehicles, how you generate electricity is another point. We can use any of these conventional petroleum-based fuels or renewable sources such as a hydroelectric power plant or a solar power plant or a wind energy plant. Now, fuel cell vehicles, how to get the hydrogen is you can either get it through catalytic reduction of natural gas or through electrolysis or from agricultural based source such as biomass. Now, to have a clearer understanding, if you see the well to wheels analysis, let's say we are taking natural gas to CNG. I'm taking this particular example because natural gas to compressed natural gas, it is a very clean fuel and there are hardly any soot particles that you will get once you burn this. So there is an efficiency of up to 85% that can be achieved in this process. The compression process itself has an efficiency of 95%. And once you get the natural gas after recovery and then you put it into the fuel tank of the vehicle, the efficiency of burning in the internal combustion engine is up to 26% is only achieved. So if you compare the efficiency from what you are getting from the well to the wheels of a CNG based vehicle, ultimately you are getting an efficiency anywhere between 11 to 22%. Now, if we use the same natural gas to produce electricity rather than put it in an engine and then drive the vehicle, so same efficiencies we get, we put it in a what you call as a gas turbine, a stationary gas turbine, and then generate electricity by coupling it to a generator. So this is what we call as a gas-based power stations. Here the efficiencies of 51% can be achieved, and the transmission and distribution efficiency is 92%. Now the electricity, once it gets to the charging point, you are at 95%. And if you consider this to the efficiency that you are getting in an EV, the total efficiency of up to 35% is achieved. So in the minimum case, 11% in CNG vehicles, and minimum case in the EV it is 22%, and maximum for a CNG vehicle is 22, whereas for the EV you can still achieve 35%. So there is a definitely you are saving on how the fuel is properly utilized, and there is a solid case for the energy efficiency here. If you see this is another this particular case, it is showing you how much carbon dioxide emissions can be that is compared to a Tesla vehicle when you are comparing it to a CNG Honda vehicle. So here 45 grams of CO2 is emitted for every kilometer in case you are running a CNG vehicle. Whereas if you consider a Tesla Roadster, which is running on a CNG based natural gas based power plant, electricity derived from a natural gas based power plant, you are emitting only 12.6 grams per kilometer. So again, the electric car shines when you see from the perspective of CO2 emissions. That is, it is 3 times better than the hybrid car and nearly 4 times better than a hydrogen fuel cell car. So this we are talking about pure electric vehicles. The next topic that I would like to introduce is what are the parts of an electric vehicle, or what are the different subsystems. Here we will be talking mainly about a pure electric vehicle. Also, we will see what are the different topologies in a hybrid electric vehicle. There are different ways in which you can achieve the same result. So basically, you will have a battery pack which is also known as a traction battery pack, which has a battery management system that sees what is that takes care of the charging, discharging, as well as the safety aspects, and this constitutes a high voltage system, and this goes to the power electronics, and the power electronics or the traction inverter along with the engine control units, it drives the electric engine or rather the electric motor. So when we see, we can have basically four different types of vehicles when we compare to a IC engine vehicle and an EV. So these are like the plug-in vehicles as well as the plug-in ground support equipments. You would have, many of you would have seen the ground support equipments that is used for material handling in airports as well as in warehouses, like forklifts and stuff. Those run on electric vehicle, the electric propulsion. That has been like it's been there since 1950s itself till date. It's very popular. Now, plug-in vehicles, plug-in hybrid electric vehicles can be a hybrid electric vehicle or a range extended vehicle or a battery electric vehicle. The difference is in a conventional IC engine vehicle, the fuel goes to drive the IC engine, and then the IC engine drives the vehicle and provides the necessary motion. Whereas in a hybrid, the engine can be assisted by the electric motor, or the hybrid engine can be used to drive a generator, and then the generator used to drive the motors. Whereas, and in this case, this is not a conventional hybrid is what we call as a self-recharging vehicle. Now there is another category of vehicle called as PHEV or a plug-in hybrid electric vehicle. Here the battery pack, the difference between a conventional hybrid and a plug-in hybrid vehicle is the battery pack is substantially larger and it provides a more higher electric range compared to a conventional hybrid. In a range extended electric vehicle, the difference is the propulsion is purely through electric means, whereas in a plug-in hybrid electric vehicle, propulsion is through the IC engine, electric motor assists the IC engine. Still, there is substantial savings in fuel. So the range extended vehicle, the difference is you get the engine would be always, there is an engine, and the engine would be running at a constant load that is required to run the generator and charge the battery, or to run the motor in case the battery is in a lower state of charge. So the engine would, the hybrid, in this case, the hybrid engine would be running at its peak efficiency and electric motor would be running at its peak efficiency. So since both systems are running at constant load, the efficiencies are higher compared to a conventional hybrid. Now in a battery electric vehicle, there is no IC engine. There is a battery pack, there is a control electronics, and there is a drivetrain which drives the vehicle. The range of the vehicle is dependent on the capacity of the battery pack. Whereas in the range extended vehicle, even if the battery pack is depleted, it is always possible to put in fuel from a normal fuel station and then continue the journey. Now the plug-in ground support equipment and compared to the plug-in vehicles, here these equipments are run on a time-based way, in the sense that the plug-in vehicles, we say the range is 100 kilometers, 200 kilometers, 400 kilometers per charge, and whereas plug-in ground support equipment, it is like it can run continuously at the rated load for a shift of 8 hours, 12 hours, or 16 hours. Coming to how an electric vehicle is constructed, or what is a system in an electric vehicle, we'll go from a simpler system to gradually to the complex systems. So basically here what we have is we'll have a battery pack. There is a power electronics which will manage both the battery as well as, we are talking about integration of the traction inverters as well as the battery management systems as well as the driver interface and the vehicle control units. This constitutes the electronics part, and the electronics drives the motor and the motor drives the vehicle. So whereas in a now once we go to the hybrid vehicle, here you can see the different parts of the electric hybrid automobile. So this hybrid, this particular hybrid is what we call as the motor is always driving the This is the one which I had talked about initially. Here the engine is always running at a constant load connected to the generator. Let's say here the motor power is like it's a 50 kilowatt motor. The engine would drive a generator which is roughly about 60 kilowatts, such as in a BMW i8, and then a computer would control when and when and when it should be stopped and when it should be started. So the generator drives the inverter through the battery. The battery provides continuous power to the inverter, and the inverter drives the motor. In case once you reach this is also called as a range extender kind of hybrid. Here, once you reach a certain range, like the vehicle is rated for 200 kilometers, then the range extender engine may, depending on the fuel tank capacity, it can take it up to another 100 or 200 kilometers by running the engine to drive the inverter directly and also charge the battery packs. How we can model an electric vehicle? That is what this particular slide is all about. So basically in an electric vehicle system, what you have is a battery pack, a motor, and the wheels as well as the drivetrain, including the gearbox. So here, the battery, the power of the battery, or what is the energy state of the battery, here we have what we call as a power sensor or a current sensor, and taking inputs from these, we derive what is the SOC or state of charge. There is another parameter called as state of health, which is taken by the, which shows how much, which determines what is the battery capacity and how much it can be used over a longer duration of time. So here the different topology is the battery provides DC current and the inverter makes it into AC. Here we can, most common one is a three-phase inverter. There are polyphase inverters, three phase is there, six phase is there, nine phase is there. So the inverter drives the motor, and now this modeling can be done through MATLAB, Simulink. There are multiple softwares and multiple modules available. So by changing the load conditions, changing the range and all those different parameters, we will be able to model a suitable system. So going into further details, in an EV subsystem, there are what you call as a low voltage system, there is a high voltage system. The high voltage system constitutes a track, what you call as a traction inverter and traction motor as that part. And the electric drivetrain is driven. So going into a bit more detail on this, here what we have is, on your left you can see the lithium ion cell packs, and there are, you can see the super capacitors as well as the pack switch and a microcontroller. Here what it does is, this gives you a system of an EV where you have a what you call as a regenerative braking capacity. So the main traction effort is given by the lithium ion packs, and when the vehicle is under regenerative braking, the supercapacitor banks, they take in the charge and then store the energy when you require it, or for such as in an instance of sudden acceleration. Then there is the, what you call as a MCU. The MCU is in all these systems, they communicate each other with different protocols. Most common protocol what is being done is CAN. So the accelerator, the brakes, the fuel gauge, all these, they have sensors mounted on them, and through various interfaces they communicate with the vehicle control unit. The vehicle control unit in turn they control the other systems. So if you take each system separately, if you take a induction motor system, the induction motor, it will have what you call as a rotation sensor, there would be a current sensor, and there would be a flux sensor. The rotation sensing shows what is the motor position. The current sensing gives what is the current load, based on which the state of charge is taken care. And the flux sense is what is the magnetic flux available in the motor, and so through that there is a calculation of how much power can be taken out. Now, if you see how the motor is working, the basic principle is whenever there is a perpendicular magnetic field to a current carrying conductor, there is a torque being produced. This is a basic principle of motor production, torque production in a motor. So by different methods, we can achieve this. So this three main types of motors can be used for electric traction. There are many different types, but prominently three different types are being used. There is what you call as a permanent magnet type, which is mostly a permanent magnet synchronous machine or a brushless DC motor. Then what you call as an AC induction motor, and then there is what you call as switched reluctance motor. We'll go into a little bit of all these motors, how it works. The permanent magnets or the permanent magnet synchronous machine, it can be having an internal or an external rotor. An internal rotor in case it is a traction motor such as used in a four-wheeler vehicle, or an external rotor such as if it is used as a hub motor in a two-wheeler vehicle. There can be a radial flux motor as well as an axial flux motor. The advantage of a permanent magnet motor is since permanent magnets are being used, the power density is higher. So highest specific torque can be achieved in these materials, in this electric machines. However, one of the limiting factors is the cost of the rare earth magnets. That is one limiting factor. Here, there is a careful system design is required for the safety as well as smooth torque delivery. You could see permanent magnet motors being used in motors used by Toyota as well as Honda. Here, this shows you how the torque or how the permanent magnet motor works. You will have an assembly of there is a rotating magnetic field created by sequential excitation of the pole pairs. You could see this A1 and A2. These are pole pairs driven by a single phase. So you could see the orange is one phase. The V1, V2, it constitutes a second phase, and C1 and C2 constitutes the third phase. So by sequentially exciting each of these pole phases, the rotor which has magnets mounted on it, torque could be produced. So this is how a brushless DC motor is. Brushless DC motor produces the rotation, whereas an AC induction motor, which is more commonly used compared to an VLDC motor, here there is a slightly lower efficiency and slightly lower torque and power, but its design is much simpler, cheaper materials, and it is lower cost than a permanent magnet machine because only copper as well as the stator materials are being used, which are readily available. But one good point is there is an inherently smooth torque delivery for this kind of machines. So here you could see how an AC induction motor is constructed. So it is what you call as a rotating transformer. The inductive currents, the rotating magnetic field created by this excitation of the sequential excitation produces torque on the squirrel cage rotor. Now, switched reluctance motor is a third type. It is similar to in efficiency and specific torque as well as power to an AC induction motor. It is lower cost. However, it produces more operational noise. So that is means a bit of careful design is required on this part. Otherwise, this is also a very good design and more commonly used. It is also a very robust machine with smooth torque delivery. One of the points that has to be considered when you are working with a switched reluctance motor is here there has to be an optimal electromagnetic as well as mechanical design along with the electronic control units. So these are even though they are very highly efficient, they have very short-term overload capability. Whereas AC induction motors, they can be overloaded. However, the pricing is quite good. Now, the next component is what you call as a traction inverter. The traction inverter is what drives the motor. So basically what you get is DC current from the DC bus from the battery pack, and then using an array of three-phase inverters, which are mostly MOSFETs or IGBTs, you derive a three-phase current which drives the motor. And this again, you could see current sensors on each of these phase lines. They they are used to see how it is being driven and then drive the motors suitably. So systems up to 650 volts are available for this kind of designs. The other important component that we have to see is what is an EV battery. There are different, it's a, the time is limited, so will be just going over to what is the basics of most of this. So electric vehicle batteries, we have different chemistries. Most commonly used is lithium cobalt oxide, lithium iron phosphate, then nickel zinc, nickel cadmium and all were used earlier. Now the prominent ones that are being used are lead acid flooded for some what do you call as the ground support vehicles, and lead acid gel for ground support vehicles, and for the mainline usages through lithium iron phosphate as well as lithium cobalt oxide. So here what we see is, in terms of power, energy and stability, the lithium ion cells have better capability and life is also good, whereas the toxicity is much less. Means it can be recycled far easily compared to when you're handling nickel cadmium cells. However, the cost is a limiting factor. So the other next portion, next subsystem that we have to do is what we call as a battery management system. So a battery management system, what it does is it sees how much charge is available in the battery pack, and then it monitors each cell on different parameters, like such as voltage, current, and temperature, and it estimates what is the state of charge and what is the state of health, and there would be a battery diagnostics also. So there are certain fail-safe conditions which it has to get into. The next is there would be EV auxiliary systems. For instance, just by putting a motor, controller, and battery pack, you could run the vehicle, but then additional systems are there, such as engine coolings, fuel, air conditioning systems, and all those. So these are being driven by what we call as an auxiliary motor system. So there would be electric and electro-hydraulic pumps that would drive our AC systems, as well as braking systems, as well as other auxiliary systems. Now, when we consider the EV charging, we can say there are three different types. What is called as a level 1, level 2, and level 3. So level 1 is what you call as a slow charge, which would be mostly an onboard charger, and which can take a domestic power input. It is usually up to 2 kilowatt to 3 kilowatt, 3.5. Level 2 is a primary charging, which is a slightly higher charging, which is up to 20 kilowatt. Again, this can be a single phase or a three phase, and it is mostly on board the vehicle itself. Level 3 is what we usually call as a commercial or a fast charging charger, and this is mostly either a direct DC link charging or a DC to AC, and then an off-board three-phase charger. Up to 100 kilowatts per charger is possible. So there were some questions on what is the opportunity for DC chargers. So there are a lot of suppliers who are doing chargers. In fact, level 1 and level 2, multiple players are there, and DC quick chargers, most of the major players are ABB and all. They are making quite good large scale systems for public transport systems, which are direct DC link chargers. Next, what I would like to touch upon is what are the different safety standards for chargers. Now we can have what you call as conductive charging or a plug-in charging, and there is also a what you call as an inductive charging, which is not so popular. So there are different charging parameters or charging standards that needs to be followed. Now regarding the EV communications and security, there are again another set of standards that needs to be followed, such as ISO 6469, ISO 17409. Each of these has multiple layers of security that needs to be adhered to one so that the vehicle runs safely. Now, EV modeling. If you see, EV modeling can be, there are certain modules available with MATLAB through Simulink, wherein we can model individually each different chemistries of batteries, as well as what are the DC-DC converters, what are the electromagnetic conditions that needs to be put in a motor, and then see the whole system, and then see how it can be simulated, so that before the vehicle is put in a what do you call as a hardware in loop testing, you can do different modelings. Now, some of the business opportunities that is possible with that is coming up along with this EV is electricity generation. Obviously, there is mostly for the utilities, but then solar power generation as well as charging infrastructure, that is one opportunity. Battery technology and manufacture, traction motor drive design and manufacture, electronic components or subsystem design and manufacture, battery replacement services, hypercharging stations, or what do you call as a quick charging stations, then mobility as a service. So we can see that there are multiple opportunities that are possible with electric vehicles. So thank you for thank you. Any questions?
Hello. I thank very much, Mr. Setu, that you're able to kind of run us through a lot of information. Can you hear me?
Can you be a bit louder?
All right. Okay. I thank you very much for taking up this whole time to give us a brief of electric vehicles and electric vehicle technologies, and it was surprising to even know that there's a predominant role of electric vehicles possibly way back in 1900s, and it's a great to see that possibly things are coming back into line. Maybe in near future we would have some of the players majorly playing in electric vehicle technologies. So it's thanks from my side to deliver the whole of the session. I will open up the discussions for question and answers. So I have unmuted all of the participants who are here. I request you, if you have any questions, you can just speak up on the call, or if it is quite a challenge for all of us to speak on the call, you can just drop a text in the chat box here. If you have any specific questions, or possibly maybe in terms of technical questions, maybe I would say that where would we see an electric vehicle with the range, and possibly a bigger range, and possibly or else and a quicker charge? What are the other commercial opportunities that are available to Encash as a business persons, maybe out here, a few of the guys who are attending the program? If you have any questions, you can drop us a text here, or you can just speak over the call. I've unmuted all of you, so the panel is open for question and answers. So looks like nobody have any questions. Anyone who have questions, kindly just, or else maybe you guys are texting over the chat bot, or yeah, you can speak up to ask any questions. Hello, Mr. Setu. I think we have a question here. That's from Adarsh.
Yeah,
He says,
others
yep,
onboard and offboard charging. Yeah.
yep.
Okay. See, what we see as onboard charging is the vehicle has a charger which is built in the vehicle itself. So the only you will have to take a plug and then put it into a domestic socket or an industrial socket. So whatever power you are getting, let's say 230 volt from the domestic outlet or a 440 volt in case it is a level 2. So the car itself will adjust the voltage required for the battery. Now, in an off-board charging, you would have seen if it has two different types. One is a DC link charging, in which let's say if the DC voltage of the vehicle system voltage is 480 volts, there is 480 volts direct DC voltage available. So there is no conversion. You are just putting 480 volt DC directly to the vehicle. Or in case if it is, and offboard charging is mostly used when you want to do the fast charger, or let's say you want to do the charging within 1 hour or half an hour. A very common example would be if you would have seen the E2Os in Bangalore, you would see a black color pin on some lithium E2Os. That is for a offboard direct DC charger.
Others, I hope that answered your question. Anybody else who have questions, you can kindly drop in, guys. So we can quickly answer the questions, and maybe we have like a couple more minutes, maybe around 8 minutes to wrap up the session. So if you have any questions, kindly drop us. We have one more question here. So the question is, Darshan says like looking at a propulsion and energy services difficulty in India, is a country ready to go electric in automotive industry?
Can you be a bit louder? I could not get that fully.
Okay, it's in the chat box. So the question is, looking at the population and energy services difficulty in India, is a country ready to go electric in automotive industry?
See, what we are saying is, I'll give you a different example. Now, one of the constraints that is being told about electric propulsion is we don't have the sufficient infrastructure to charge all these vehicles. Now, charging infrastructure in the sense of public charging is certainly lacking. However, domestic charging is still possible, as well as when you are considering mobility as a service, consider it in this way. For instance, if you have all your Uber and Ola vehicles retrofitted with electric motors and battery packs, charging them would not be a big challenge because they would be charged at certain centralized stations, but they will bring down the emissions. So we need to look in the aspect of not about personal ownership of vehicles, but mobility as a service, wherein electric propulsion is being used for whatever logistics as well as transportation needs we have, and thereby saving all the fuel. So operational expenses can be saved. Okay, another question is, what is state of charge and depth of charge? Now, let's say you have an electric car and the car is designed to go for about 100 kilometers. Now, in a normal car, when you go, you have what you call as a fuel gauge. You look at the fuel gauge, it says in older vehicles, it will say the fuel is quarter, it is half tank, it is three-fourth, or it is full tank. Then you will have an idea of how much the vehicle can travel. Nowadays, in the newer vehicles, it will say the vehicle can go for about 100 kilometers or 150 kilometers, or when it is fully filled, such as in certain vehicles, it will show the full tank can take you about 400 kilometers. Now, same way, in a battery electric vehicle, the state of charge indicates how much with that particular level of charge you are able to move a certain distance, or you are able to cover a certain distance. Now, depth of charges, a battery has a certain energy capacity. Let's say you have 100 Ah battery pack. So 100 Ah battery pack, and let's say for calculation purpose it is 12 volts, just for, so the power density is 12 into 100 or 1.2 kilowatt hour is the battery pack energy density. Now how much you can deplete it, and then after recharging it, if you are able to get that full charge, that is what you call as a depth of charge. So lithium ion batteries, if you are saying, we will say we have a typical lifetime of about 800 to 1500 charge cycles till 70% or 80% depth of charge. What that means is the battery pack that you could use for about, let's say, 1000 charge cycles, it will give you this. For 1000 charge cycles, the battery will give you the same capacity. After 1000 charge cycles, it will give you only 80% capacity. So the depth of discharge, depth of charge, that is about 80%. 20% is lost after the certain life cycle. So that is the difference.
Yeah, that's, I
Now
think.
this, yeah.
Yep. Sorry. Go ahead.
Yeah, so this state of charge and state of health and all these estimations, there are different, what you call as, there are different, see, Kalman filter, it is a type of algorithm that is developed with which you can estimate all these. Any other questions?
Okay, guys, I think we have 3 more minutes to take up some questions. So kindly do drop in any questions if you have.
See, the topic is quite vast, and so the time is
Yeah.
very less. So that is also an issue.
Right. Yep. Certainly, I think we can always answer your questions. If you have any questions, you can always drop us at uh, contact@competences factory. I'll just drop a email ID here.
Yeah, regenerative braking. See, an electric motor, what it does is, same motor can be used as both the generator as well as a traction machine. In a traction mode, what it does is it drives a vehicle. Now, when the vehicle is trying to stop, you are taking the foot off the throttle and not giving any electricity to the motor, but the wheels are turning. So, when these wheels are turning, it is still the motor is still rotating, and the rotation of the motor produces electricity. This electricity can be routed back to the battery pack. So this is what you call as a regeneration or regeneration of the electricity, and this happens while you are braking. So this can be used to charge the battery pack to a certain amount. Up to 30% regenerative braking is possible without compromising on the comfort of driving.
Uh, Anybody have any other questions? So kindly do drop in. Perfect. I think looks like maybe we have the last questions as a one from others. Uh, Great, guys. It's a pleasure for all of us to discuss on electric vehicles and possibly to see a participation of all of you in the part of electric vehicles in the near coming future. Uh, so the whole objective of organizing this webinar is to collect sort of like-minded people who work in electric vehicle technologies and kind of construct a team or build a set of people where we can work on technologies into electric vehicles. So as a part of Competence Factory, we are planning on few projects to develop electric vehicle, which could be something like an open source platform. So anybody who want to build an electric vehicle on that platform is just open source. You can just take out sort of designs from us and possibly build an electric vehicle. As of now, the whole thought is in the ideation stage. All the set of key contributors has been discussing with us that how we can do it, and suddenly everything comes into your financials as much as possible. So we're working on smaller scale projects as of today on subsystem level. We got a couple of requests also with certain institutions to partner and kind of develop this basic systems available maybe at a subsystem level today. Definitely, we are open enough to discuss any of an opportunity if you'd like to explore with us in the future. Maybe in terms of technology, or if you would like to, maybe you need some sort of consulting in the area of electric vehicles for your company, or maybe if you'd like to learn something more on electric vehicles, or maybe it is possibly that you want to build an electric vehicle as an hobby. Maybe or else it could be a retrofitment of your own bike or a car or a bicycle as an electric vehicle. So we're definitely open enough to explore an opportunities with you. Uh, Glad to see all of your participation on Saturday, taking your time out close to an hour and participating in this webinar. Uh, so great, my pleasure. Thanks to Mr. Seturaj and his whole team to take your time, helping us out in creating a content and making your time to deliver this whole of the program with your busy schedule, things like that. We definitely look forward to have your same cooperation in the future. So I thank you on behalf of our Competence Factory team for taking your time and delivering the session. So definitely my heartfelt thanks to all of the participants who are a part of this program and taken up an hour of time to understand more on electric vehicles. We definitely look forward to possibly see you in the upcoming programs. I'll just drop you a feedback form, so if you're very much interested to learn about subsystem levels, or even which might be a very specific topic. Maybe it could be a safety of an electric vehicle, or it could be in specific, which would be high voltage safety. Any of such kind of a topics, definitely we would be able to kind of touch base on it. So I'll just drop you an email with the feedback form. You can just let us know what kind of topics you would be expecting for. Definitely we can plan to organize programs which can help you to understand those subsystems or systems as a such level. So pleasure having you, everybody. Thank you very much again for your participation in this whole webinar. Have a good evening. Have a good weekend ahead. Have a good time. Thank you very much. Take care.
Thank
Bye.
you.
Thank you.